To follow up our solving logarithms section from yesterday, we're going to take the next step, which is solving an exponential equation. When we use the term exponential equation, it refers to any equation with a variable in the exponent. So this is something that we have never solved before. 3 to the x power equals 27. Now we can common sense our way to that answer, most of you can, but what we're looking for here is what's a method that would solve an equation like that works all the time. And so therefore, we have to look at our properties that we've learned over the last few days and look at how that can help us. And so the first property we're going to look at is the power property. And this is where logarithms become very, very powerful. That's not just a nice play on words. The power property makes logarithms very powerful because we can take any exponent we're taking a log on and move it in front and write it as a multiplication. And so that is very, very powerful because we're going to use that to solve exponential equations. Up to this point in our math careers, we had no ability to solve that equation. 3 to the x power equals 27, we didn't have an inverse property, an inverse operation for an exponent. Now we do. To solve an equation like this, 3 to the x power equals 27, we're going to take the log of both sides. Log is just an operation, and remember, if we're taking a log, not writing a base, it's assumed log base 10, and we're choosing that because we're going to use our calculators, and our calculators will do log base 10. So this x can then be pulled in front of the problem. So we have x times log base 3 equals the log of 27. And to finish that then, it's a simple equation. If I had 5x equals 10, I would divide both sides by 5. So if I have x times log 3, to get x by itself, I divide by log 3, which makes it log 27 divided by log 3. You can then punch that into your calculator. Log 27 divided by log 3 is 3, which should come back to our common sense answer up here that says 3 to what power is 27? Well, that's 3 to the third power. 3 times 3 is 9, times 3 is 27. So this is our method we're going to use to solve an equation where you have a variable and an exponent. At some point, you will take a logarithm of both sides, allowing you to pull that exponent out and turn it into a multiplication. Let's look at another example. In this example, you notice there's operations included with the exponent. And so in this case, we need to be able to get that exponential portion of the problem by itself. We have 3 times 2 to the x minus 5 equals 7. We're going to solve for that 2 to the x before we do any logarithms. Now, for whatever reason, when I've taught this in the past, students have struggled with the order of operations here. We treat this just like 3x minus 5 equals 7. I need to solve for x. If I do that, all of you would add 5 first. We do the same thing here. We add 5 first. For whatever reason, in previous classes, people wanted to divide by 3 first. I don't know why, but that's a common mistake. So that gives 3 times 2 to the x equals 12. Divide by 3. 2 to the x equals 4. Now, again, this happened to work out to one that you could do using common sense, but we also could use our log properties to say I can log both sides. The log of 2 to the x is equal to the log of 4. We can do an operation in algebra as long as we do it to both sides. The x comes out front, so it's x times the log of 2 equals the log of 4. That should not be a base, that's just a habit. Divide both sides by log 2, so you take your calculator and do log 4 divided by log 2, and you get 2. Which again, we can look back up here and use common sense to say 2 to the second power would equal 4. But if it equaled something like 2 to the x equals 7, then we would not be able to get the answer without the logarithms. So let's look at an example now that's going to take a couple of extra steps. First of all, this one will not work out to a nice, neat answer like 2 or 3. It's going to work out to a decimal. And the other piece of this is going to be, you're going to have to do an extra solving step in this case as well. So, to begin with, we're going to add 6 to both sides. So you get 2 times 5 to the x plus 4 equals 60. Then divide by 2. We always want to solve for what has the x with it first. Get that exponential by itself. Now, we're going to take the log of both sides, which allows us to pull x plus 4 out front, and it's the log of 5 equals the log of 30. Divide both sides by log of 5. That leaves x plus 4 equals a value that we'll get by simply using our calculators and taking log 30 divided by log 5. Be careful with your decimals. Be careful with your parentheses to make sure you close the parenthesis after the 30. And x plus 4 equals 2.1133. And I'll always carry some extra decimal points in these problems, because when you're talking about logarithms, you're talking about an inverse to an exponent. And so that an exponent, those decimal places have a much larger impact when you're talking about an exponent than they do on most problems. So therefore, we'll always carry our answers to 3 decimal places. All right, good luck with your solving exponentials, and have a nice weekend.